Okay. So next one is, yes, the fifth general method. Here it is taking soluble salt solution. Okay. Soluble means dissolving public curry powder means soluble, taking soluble salt solution, and for that we are adding caustic alkali solution. Alkali in the sense it is a soluble base. Okay. So if we add these two in the reactant side, what do we get the product? We get products such as insoluble metallic base and water. Insoluble means it doesn't properly dissolve in the particular solution. Ante sariga mix avakunda, the leftover ones in the for example, if you take water and sand, what happens? It is doesn't dissolving, no? It is, it will settle down. Yes, that is called as insoluble. Okay. Whatever soluble, example is taking water and salt. If you add a pinch of salt, the water solution, what happens? The water, what happens? The salt solution is completely mixed thoroughly and there is no particular visible boundaries present. Okay. So soluble salt solution plus caustic alkali solution, if we take these two, what do we get? We get insoluble metallic base and salt. Okay. So we'll see how it goes with examples. Okay, children. So first one, we have two examples over here. We'll take one by one. First one is, let's take the soluble salt solution is aluminium chloride here. Okay. AlCl2 means named as aluminium chloride. Once again, aluminium, yes, aluminium chloride. AlCl2 is aluminium chloride, and for this we are adding sodium hydroxide. It's a caustic alkali solution. We are taking, here it is, you already know, 3 molecules of NaOH. What is NaOH called as? Sodium hydroxide. Very good. So for this, both aluminium chloride and 3 molecules of sodium chloride, when these two both react, we get this particular insoluble metallic base. What is that? It is AlOH thrice. AlOH thrice. When you see the number, this, it is 3, children. It is 3. And if it bracket is there, and if the subscript you have 3, that is named as thrice. Okay. Did you get that? And here to read as AlOH thrice. Okay, not 3. AlOH 3 is not correct, and it is written as AlOH bracket 3, no, but read as AlOH thrice. You know what is the name of this? Try the name. Al means aluminium. Very good. OH thrice means OH is something directly hydroxide. Yes. Oh yes. Okay. Now we do also get salt. I told you, what is the salt liberated here? NaCl is, yeah, the table salt sodium chloride. Very good. Children, did you observe any particular arrow, any differentiations from the previous things, previous equations? Yes. What is that observation did you observe? Tell me. Yes, arrow mark, which is downwards. What is the meaning of that particular downward symbol? Did you see the word insoluble? Insoluble means it doesn't mix in the particular solution. So that's the reason we'll say it is settling down in that particular test tube or the particular beaker, we have to say. Okay. The down arrow mark is insoluble. Okay, I'll name after for you. Shall I write here? Yes. Children, we do have some equations, and in that we will observe some arrow marks representations. Okay. I'll write what is that arrow mark, because you have seen so many regarding chemical equations in the chemical equilibrium something lessons we do have, no. So in that we have some special reactants, products, left hand side and right hand side too, and in that we have some arrow mark representations. For example, if you look here, there is a representation arrow mark from left to right. Okay, it is showing towards the right hand side. Yes, right. This arrow mark is named as irreversible reaction, and if it is double arrow, what do we call that as? You know what is that? Here we go. I'll write all that for you. Just remember the key concepts. Okay. If it is only one arrow mark, we have to name it as irreversible reaction. Irreversible reaction. Children, always this side is left hand side and this side will be right hand side. Okay, left hand side we do have reactants and right hand side we have products. Okay, so if it is double arrow mark, dual arrow mark, what do we call that as? See, one arrow mark like this and reverse. If it is dual arrow mark, you know what we call it as? We call it as reversible reaction. What is that? Reversible reaction. Reversible reaction. And now, if the arrow mark is represented from bottom to top, if it is showing upward direction, what do we call this as? Come on, tell me. What do we call the upward arrow mark representation in the particular chemical equations, especially reactions wise? That is called as gas, which is liberated into the atmosphere. So it is going away, no? Escaping from the beaker, we'll say that is gas representation. Okay, small g. We'll write like this. Okay, and if it is towards the downside, what do we call that as? You know what we call that as? Just now I told you, know. Yes, it is something insoluble. We named it as PPT. Means that doesn't dissolve and that is forming like a precipitate. What is that? Precipitate. The name of PPT is nothing but precipitate. So if you see such arrow marks representation of particular chemical equations, these are the meanings behind that. If it is single arrow mark, irreversible reaction, dual arrow mark, double arrow mark, reversible reaction. If it is going from top to bottom, upward direction, it is gas. Downward direction, it is precipitate. Means karigipokunda leftover thing untundi kada beaker lo gaani, test tube lo gaani, that the thing. Okay, that is insoluble matter present in the beaker, which is not dissolving further and also not going away. It is simply settling down beaker, that is named as insoluble or else PPT, precipitate. Okay, not PowerPoint presentation. Okay, this is all about the particular arrow marks in the particular chemical equations. For general idea, I told you all these things. Okay, children? Yes. Now coming back to the example. Now here you have no. First example is aluminium chloride. To that we are adding 3 molecules of sodium hydroxide. What do we get? We get an insoluble metallic base, that is aluminium hydroxide, which is ALOH thrice, which is having downward arrow mark, which means it is a precipitate, insoluble matter. Okay, and we also get a salt, that is here 3 molecules of what do we get? Sodium chloride 3 NaCl. Okay, this first example. Clear, children? Now moving to next example, that is CuSO4. CuSO4. What is CuSO4? CuSO4 is named as what? Cu means, I told you before, the Latin name cuprum. What is Cu? Very good. Copper. SO4 means sulfate. Copper sulfate. And to that we are also adding again sodium hydroxide. Now this time we are taking only 2 molecules of sodium hydroxide, and to that we are adding copper sulfate. So what do we get? We do get an insoluble metallic base again, that is different in the particular condition of this example, that is CuOH twice. If it is 2, read as TWO2. If it is bracket 2, it is twice. Yes, twice. Okay, difference you have to read. CuOH twice, which means it is called as copper hydroxide. Very good. Copper hydroxide. And we also get a salt, that is Na2SO4. What is the name of that? Na2SO4 is named as, come on, tell me. Na2 means sodium, SO4 means sulfate. Sodium sulfate. Children, you already got all this. See, by doing number of examples, you'll get the names of the particular elements and also by the particular compounds. Okay, it is Na2SO4, so sodium sulfate. Simply got it. Very good, children. So here we also have the particular down arrow mark, which is representing it as an insoluble matter, which is insoluble metallic base, and it is having a What is that? Precipitate nature. Okay, PPT. Okay, got it? These two are the examples of the fifth general method for the preparation of base alkali, that is just adding the soluble salt solution with that of caustic alkali solution. What do we get? We get insoluble metallic based, and also we get salt. The first example, if you observe, we get, what do you observed? When we add aluminium chloride to that of 3 molecules of sodium hydroxide, we will get aluminium hydroxide as well as a salt. What is salt here? Sodium chloride. Very good. Now, for the second example, we have taken copper sulfate. For that, we have the basic. What is that solution? Sodium hydroxide again, and to that we have getting the products such as copper hydroxide and salt, sodium sulfate. So, what are the salts here? Different salts based on the particular taken different. See, we have taken different salt solutions. Now we are getting different salt here in the particular product side. Okay, but the alkali solution is same, and the particular metals change, aluminium and copper, all these things. Okay, based on particular equation, you have to remember what are the reactants, also what are the products. Okay, so this is all about the particular fifth general method. Hope you understood clearly how to read it. What is the arrow marks representation? Yes, very good. Children, here for reversible reaction, we also have generally what we observe in the particular equations means they'll write 2 lines, and for that they'll just add like this and like this. That's it. Okay. No, they'll not keep any arrow mark like this. See, 1 arrow mark and down a mark. Okay, this is neglected, and we'll use this. Most probably we'll use that. And we'll use sometimes this also, but now if you observe the books, you'll get these only. Just half upward and half here down. Okay. This representation of the arrow marks, do you understand now? Down means it is insoluble precipitate. Yes. Now moving to the sixth general method, that is by strong heating of metallic carbonates. Once again, by strong heating of metallic carbonates. Here we have exceptions. We have 2 exceptions. Those 2 are Na2CO3 and K2CO3. What are the names of Na2CO3 and K2CO3? Anybody? Any try from your side, children? See, every time if I am only telling you, when you will get. Okay, I'll help you. What is Na2? Very good. Sodium. Na2 is sodium. Na2 is sodium. CO3 means, come on, try. C is carbon, O is oxygen, O is having 3. We name it as carbonate. Who is that? Very good. Good job. See, carbonate. Sodium carbonate. Read it after me. Sodium carbonate. Now, try for second one. K2CO3. Come on, do it. K2 is potassium. Very good. See, you got by number of practices, you will get potassium. CO3, carbonate. Very good. Because we have here no carbonate. Simple. Okay. Children, see here we have 2 exceptions. First one is sodium carbonate and the other one is potassium carbonate. Except these 2, we can have a safer strong heating of all the particular other metallic carbonates to get a liberating of particular alkali or a base. Okay, we'll see what is that particular equation. We are taking metal carbonate. Here examples are CaCO3 and CuCO3. Okay, for that we are just involving the presence of heat to get a basic oxide. Namely CaO and CO for the particular 2 examples. Okay, and we also get a particular gas here. You know what is that gas here? Carbon dioxide. Once again, carbon dioxide. G means gas. Upward arrow mark or downward arrow mark? Very good. It is upward arrow mark. G means upward arrow mark, no? Okay. So here we have carbon dioxide is gas and taken the basic oxide, the liberation of particular reacting of the particular metallic carbonate with that particular of heating. By strong heating of metal carbonate, we do get the two things. What are the two things? Basic oxide and also carbon dioxide gas. Okay. So here we'll take examples number 1 and 2. What is first one? CaCO3 is named as, come on, Ca means calcium, CO3 carbonate, very good, calcium carbonate. For that the presence of heat, strong heating, no? So heat. We can also the symbol triangle over here in the presence of heating. Okay, this, or also we can write this, no problem. Okay, next, in the previous equation you saw the triangle symbol, no? That is presence of heat. Okay, and we got basic oxide, that is calcium oxide, and also carbon, yeah, we have here carbon dioxide gas, Okay, this is the first example, children. Okay, if you are taking calcium carbonate directly by strong heating, we do get calcium oxide and also carbon dioxide. Where do we get carbon dioxide? From this carbonate. We have here carbonate, from that we are getting carbon dioxide. Okay, so the calcium oxide separates and carbon dioxide liberates in the atmosphere, that is gaseous form, G. Okay, now next example is CuCO3. What is CuCO3 is named? Named as copper carbonate, and to that liberating, by acting of strong heating, what do we get? We get a simple basic oxide, that is copper oxide and also carbon dioxide. What is this? Carbon dioxide. Carbon, it's mixing once again. Yes, carbon dioxide. Okay, yes, these are the examples for the particular sixth method for the preparation of base. By what? By taking a metal carbonate, to that we are just adding a strong heating, and with the strong heating of metal carbonate we do get particular basic oxide and also carbon dioxide gas. Okay, children, so we have two exceptions in the particular method. What is that? The two exceptions are sodium carbonate and potassium carbonate. Except that we will take other metal carbonates to do get a basic oxides and also a carbon dioxide gas. Okay, first example is calcium carbonate, strong heating, calcium oxide and carbon dioxide gas. And second one, taking copper carbonate, upon strong heating we do get copper oxide and also carbon dioxide gaseous form. Okay, this was the first and second example regarding the sixth method. Okay, and the last, yes, we have the last the last method for the preparations of base. This is by heating nitrates of metals from calcium to copper. Calcium symbol capital C small a, and copper symbol capital C small e. Okay, so from calcium to copper, what we are taking? We are taking by heating nitrates of metals from calcium to copper, and in which what? In electrochemical series. Very good. So we are taking metal nitrate, to that again heating process. Heating, before is also strong heating only, this is also heating. So we have written here heat, or we can write triangle symbol also. Okay, so upon heating of this metal nitrate, what do we get? We get a basic oxide like the previous one only, children, and to that we are getting different gases. Before equation we just got carbon dioxide. Why? Because we are taking carbonate, basic oxide and carbon dioxide. But here we are getting two separate things. What are the? Nitrogen dioxide and oxygen. Why nitrogen dioxide and oxygen? Because we are taking nitrates, no? Because we are heating nitrates, no? That's the reason we get nitrogen dioxide and water. Oh, sorry, oxygen. Okay, but before we are taking carbonate, we got carbon dioxide. Here we are taking nitrates, so we will get nitrogen dioxide and also oxygen. The basic oxide is common. Okay, children? Yes. So, in the previous particular example, we have taken the same calcium and copper. Here, calcium carbonate and copper carbonate. Now, if you observe, here also calcium, here also copper. But in the presence of the place of carbonate, we got nitrate. What is that? Nitrate. So, we'll write the names now. What is the name of CaNO3? Okay, you read it. How to read it? How to read the particular formula? Read it out. Tell me. Leave the 2. 2 is just balancing molecular equations. Okay. CaNO3 twice. Very good. What is the name of CaNO3 twice? Calcium nitrate. How to read? Okay, 2 also. 2 Ca. What is that? NO3 bracket is there. No, how to read this 2? Very good. Twice. Okay. Twice. Yes. So, calcium nitrate. Okay. 2 CaNO3 twice. And to that, upon heating, what do we get? We get a basic oxide. You know already. What is this? 2 CaO, copper, calcium oxide, and we also get nitrogen dioxide, 4 molecules of nitrogen dioxide, also oxygen gas, dioxide and oxygen gas. Okay, children? Yes. The second example is same. The previous carbonate we have NO3 thrice, NO3 twice in the place of CO3. What is that? Name 2CuNO3 twice. The name of this is copper nitrate. Upon heating, what do we get? We get a basic oxide is copper oxide, also nitrogen dioxide and oxygen gas. Okay. This is the particular examples for the 7th, the last general method for the preparation of base or alkali. What is that, children? Just simply we are taking a metal nitrate. In the place of metal carbon, we are taking metal nitrate, NO3 twice. So, for that, we are doing heating. Upon heating, we will get a basic oxide by taking particular elements, metals, nitrate. Okay. For that, we are also getting 2 other products. What are the 2 other products? Nitrogen dioxide and oxygen gas, namely. Okay. This is all about the particular examples of the particular 7th method. Okay. Again, once again, by heating nitrates of metals from calcium to copper in electrochemical series. We have a special series, children, electrochemical series. In that, from calcium to copper, we are taking all the nitrates. Okay, namely from calcium nitrate to copper nitrates. Okay. Examples for the particular equation: metal nitrate gives rise to, in the presence of heat, we get basic oxide, nitrogen dioxide and oxygen. And we have taken 2 examples, that is calcium nitrate. Upon heating, we do get calcium oxide, nitrogen dioxide and oxygen gas. Okay. And second example, copper nitrate. If we do upon heating, we get copper oxide and nitrogen dioxide and also oxygen gas. This is the method, general method for the preparation of base. By this, we can prepare basic oxide of particular. Here we have 2CaO, 2CO. These 2 are the basic oxides. This is nitrogen dioxide, this is oxygen. Okay. Gas G means gaseous form. Okay. These are the 7 methods for the preparations of bases or alkalis. See, if you see the arrow marks here, heating and heat. These all are single arrow mark, which means it is a irreversible reactions. Okay. Arrow marks here. Okay. Did you observe all these things? No. These all are the, see here triangle in the sense upon heating. Here also triangle which means upon heating. Okay. So, these are the 7 main methods, the present methods of all the preparations of bases or alkalis. Okay. So, once again for you, okay, these are the 7 preparations to get bases or alkalis. Okay, hope you understood the session. Thank you all.